When you grab a bottle of spring water at the convenience store, you probably think you're making a healthy, responsible choice.
Right, yeah, for your body.
Exactly. You picture this pristine glacier or, I don't know, a hidden mountain stream completely untouched by civilization.
Oh, definitely. The classic marketing image.
But when you actually look at the data, the reality is a whole lot less scenic. I mean, when you buy that plastic bottle, you are likely paying a staggering 3,000% markup for what is essentially just filtered city tap water.
Yeah, I mean, it is a number that completely recontextualizes the entire beverage aisle for you. 3,000%.
It's wild.
It really is. And to understand how a markup like that is even possible, let alone, wisely accepted by consumers, we have to look at the structural reality we're living in right now in 2026.
Right.
We are dealing with a 160-year-old municipal water grid that is, well, it's fundamentally snapping under our feet.
Yeah, it's basically Victorian infrastructure.
Exactly.
Yep.
Built in the late 19th and early 20th centuries. So we are running modern, booming populations on cast iron pipes, lead soldering, and just decades of deferred maintenance.
Which honestly perfectly explains why people are so desperate for an alternative that they'll pay that massive premium.
Right, out of fear.
Yeah, you turn on the tap, you see brown water, or you get a boil advisory on your phone, and suddenly that plastic bottle looks like a pure survival necessity. It makes me think of a structural trap, relying on this failing municipal grid and then turning around to pay a massive markup for bottled water sourced from the exact same regional supplies.
It's a great point.
It's like paying rent on a house you already own, but the landlord is refusing to fix the plumbing. Actually, no, the landlord is slowly poisoning the water supply, so you have to buy your own water back from him in tiny plastic cups just to survive.
Wow, yeah. That structural trap is the exact premise of the materials we are analyzing today. The source we're looking at, which includes a rather provocative video pitch and an accompanying guide, takes a highly skeptical stance toward both utility monopolies and big water corporations.
Very skeptical.
Yeah, they argue that these entities are essentially banking on your dependency as the public system degrades. But what is really compelling, and what we're aiming to impartially explore in this deep dive, is that they don't just point out the problem. They actually outline a transition from that complete dependency to total self-sufficiency using a DIY concept called the smart water box.
Okay, let's unpack this. Because the materials, they really don't pull any punches when it comes to the actual quality of that bottled water we're all falling back on.
No, they don't at all.
We aren't just talking about a financial ripoff here. When you actually look at the chemical analysis provided in the text, you find that before that bottle even makes it onto a refrigerated shelf, microplastics and forever chemicals like PFAS are leaching directly into the water.
Right, just sitting there.
Exactly. The manufacturing process of the bottle itself, combined with the heat exposure during, cross-country shipping, it degrades the plastic.
Yeah.
So you are paying a 3,000% premium to ingest industrial byproducts.
The irony there is just, well, the consumer believes they are buying purity.
Right.
And this highlights a fascinating psychological angle that the source backs up with data. Nearly 78% of consumers choose products based on perceived credibility.
Wow, 78%.
Yeah. Big water brands leverage these massive marketing budgets to construct an image of absolute safety. But logistically, the text notes that the vast majority of these brands are simply tapping into municipal sources.
Right, the exact same sources.
Exactly. They're running water from the exact same corroding, century-old pipes through an industrial filter, slapping a mountain logo on it, and shipping it back to you.
So you aren't paying for glacial runoff.
No.
You're paying for petroleum-based plastic, the diesel fuel required to transport heavy liquid across the country, and basically the psychological comfort of a television commercial.
That's a perfect way to put it. And the source categorizes this specific brand of reliance, this illusion of safety you find on a grocery store shelf, as point A.
Point A.
Right. Point A is defined as a state of total systemic vulnerability. Think about the logistics for a second. If regional droughts worsen, or if a major municipal pipe bursts,
Which happens all the time now.
which that text notes is happening with increasing frequency, yeah, the corporations controlling the bottled water supply are subject to the same shortages.
Right.
They will inevitably hike prices while the quality continues to degrade. So if you rely entirely on a commercial supply chain to hydrate your family, you have zero leverage. You're stuck.
Which raises a critical, Almost uncomfortable question for you listening. If the grid is failing under our feet and the premium water on the shelf is just repackaged municipal water slowly marinating in microplastics, where exactly does that leave you?
It's a bleak picture.
It is. Because if the ground sources are compromised and the pipes delivering it are decaying, you are essentially boxed into a corner.
You are. Well, provided you limit your search for water to the ground.
Oh, right.
The source's entire thesis hinges on a very simple pivot. If the earthbound grid is a dead end, you have to look up. You have to look to the atmosphere.
So what does this all mean? The source uses a term I find incredibly interesting. They call it influencer science.
Yeah, that's a great term.
It describes this movement of everyday people bypassing traditional gate-kept engineering silos. It's totally decentralized, open-source problem solving. And the application they're focusing on here is atmospheric water generation.
The thermodynamics behind atmospheric generation are genuinely remarkable. And the guide, it breaks them down into highly accessible principles.
Right, making it easy to digest.
Exactly. We are conditioned to think of water geographically, rivers, lakes, subterranean aquifers.
Yeah.
But the atmosphere is actually a massive, constantly replenishing reservoir. The text points out that even in an arid desert environment with a relative humidity of just 10%, there are billions of tons of moisture suspended in the air.
Wait, billions? Even in a desert?
Billions of tons, yes.
Yes. That completely flips our understanding of geography. We think of a desert as a dry, barren wasteland, but atmospherically, it's just an invisible ocean waiting to be tapped.
And tapping it requires nothing more than a phase change. The core mechanism is condensation.
Okay.
By drawing ambient air over a cooled surface, specifically cooling it below the dew point, you force the water vapor to change from a gas back into a liquid state.
Right. Basic science class stuff.
Exactly. But what the source emphasizes heavily is the resulting purity. Because you are forcing a phase change from vapor to liquid, it acts as a natural distillation process.
Oh, because the heavy stuff can't evaporate.
You got it. Heavy metals, industrial runoff, ancient lead particulates, they cannot evaporate. They stay on the ground. So the moisture you pull from the air is inherently pristine.
What's fascinating here is, well, the text actually frames this using a great concept called niche bending.
Niche bending. Yeah, it is a brilliant way to describe the democratization of technology.
Exactly. Atmospheric water generation isn't a new concept, right?
Yeah, not at all.
Military bases use it. Massive agricultural operations use it. But those are like $2,000 industrial scale machines. Niche bending is taking those heavy-duty commercial physics and compressing them down into a DIY survival application that just fits in your backyard.
Right.
If I can use an analogy, the mechanics are basically the same as a common household dehumidifier. You know how a cold soda can sweats on a porch in the summer?
Oh, sure. Yeah.
It's that exact same thermal reaction, but engineered specifically for high-yield, food-safe extraction. It's effectively giving you a personal cloud trapped in a box.
A cloud in a box. I love that. But theoretical physics and soda can analogies are useless if they don't survive contact with reality.
Fair point.
Yes, we all know condensation exists, but engineering a system to rapidly, efficiently capture that moisture without burning out a compressor or leaching chemicals from the machine itself usually requires specialized knowledge.
Yeah, you'd think you need an engineering degree.
Which brings up the obvious hurdle. How does the author expect an average person who, maybe struggles to assemble flat-pack furniture to execute the thermodynamics of atmospheric generation?
Here's where it gets really interesting. Because the guide claims to completely strip away the complexity of the build. They actively address that intimidation factor. The blueprint for the smart water box is described as Lego style. You do not need to be an HVAC engineer. You don't need a fully equipped machine shop.
Right.
The source provides a modular step-by-step video walkthrough.
And the supply chain requirements for this build are shockingly minimal.
Yeah, tell them about the parts.
According to the parts list in the text, there are no proprietary specialized components that you have to special order from overseas.
Which is huge.
It is. The entire system is assembled using standard parts available at literally any local hardware store. We are talking about basic high-efficiency DC fans, a simple compressor, and food-grade tubing.
Right.
The total estimated cost to build a unit from scratch is between $50 and $200.
That barrier to entry is almost non-existent, especially when you compare it to the compounded month-over-month costs of utility bills and 3,000% marked up bottled water.
Absolutely.
But what really made me stop and reread the text were the output specs. A $50 box built from hardware store parts sounds like a fun, weekend science fair project.
Right, the neat trick.
Yeah. But the source claims this specific build can extract up to 40 gallons of crystal clear water every single day.
40 gallons is a massive volume of water.
It's huge.
To put that into a domestic context, the average person requires about a gallon a day for hydration. The text notes that 40 gallons is more than enough for a family of 4 to drink, cook all their meals, and even maintain a small survival garden.
Wow.
All completely independent of the city supply.
And it achieves that volume without spiking your power bill. The text states the smart water box runs on less energy than a standard kitchen toaster.
That's the craziest part to me.
Right. Because it relies on a continuous low-wattage heat exchange rather than bursting massive amounts of power to generate heat. It is incredibly efficient. Plus, they note it can be hooked up to a single solar panel, giving you a 100% off-grid setup.
Yeah.
But I have to push back here because if I'm listening to this, my alarm bells are ringing. It sounds almost too perfect.
Oh, for sure.
40 gallons a day from a $50 box, using less power than my toaster. Thermodynamics is an unforgiving science. You really have to wonder how a cheap fan and a basic compressor hold up outside of a controlled laboratory setting. Does this actually hit the dew point efficiently in the real world, or is it just a clever theoretical model on paper?
That skepticism is entirely justified. And it's exactly why the source dedicates the next section of the material to what they term radical transparency.
Transparency.
Yeah, they recognize that extraordinary claims require empirical evidence. They don't just hand over the blueprints and walk away. They provide real-world case studies to validate the structural integrity of the build. And they start with the ultimate stress test. This guy, Mark from Arizona.
Arizona is the perfect proving ground. If you are going to test an atmospheric water generator, you take it to the high desert.
Exactly.
It's arid, the ambient heat is brutal, and you just assume the machine would run constantly without producing a single drop.
The assumption is that low relative humidity means no water. But the physics of absolute humidity dictate that the moisture is still there. It just requires a slightly more efficient thermal exchange to extract it. According to the source, Mark built his system using the guide, took it out into the desert, and the machine successfully forced the phase change.
Wow.
But Mark actually addressed the exact concern we brought up earlier regarding purity. He didn't just drink the water. He sent the output from his DIY box to an independent professional laboratory for a chemical analysis.
And the lab results confirmed the science. Because the vapor-to-liquid phase change leaves heavy particulates and ground pollutants behind, Mark's homemade air water was demonstrably cleaner than the premium bottled brands he had been buying.
Isn't that wild?
It's incredible. The lab proved that you don't need a multi-million-dollar corporate facility to achieve absolute purity. You just need to understand basic thermodynamics.
Right. And then the text shifts from Mark's extreme survivalist application to a more domestic, everyday scenario with a second case study.
Right, Sarah.
Yeah, they introduced Sarah. She's a mother who was not necessarily worried about desert survival, but was simply exhausted by watching her utility bills endlessly climb while the municipal water quality degraded.
I think almost anyone listening right now can relate to Sarah's position. The financial squeeze of basic utilities is just a universal pain point right now.
Oh, absolutely. The text details how Sarah sourced the materials and built her smart water box in a single afternoon. The immediate result was a permanent, free supply of pristine water for her family.
Incredible.
But the underlying value is the systemic detachment. If a municipal main breaks down the street, or if the city issues a chemical contamination advisory, which, as we know, is an inherent risk with a 160-year-old grid, her household is structurally insulated.
She's totally unaffected.
Exactly.
Unaffected.
And if we connect this to the bigger picture, the source is articulating something much deeper than a weekend DIY project. They are pushing for a fundamental psychological and economic shift. They use a very specific phrase. They ask if the reader is tired of being a tenant to the water company.
Yeah, tenant.
That word, tenant, is heavy, because a tenant has no equity and no control. A tenant is entirely at the mercy of the landlord's maintenance schedule and their pricing models. By engineering your own supply, the source argues that you are legally and literally escaping tenancy.
The smart water box is basically positioned as a financial escape hatch.
It is not just a dusty doomsday prep sitting in the corner of your garage. It's an active, daily utility. The text argues that the $50 to $200 upfront cost pays for itself within just a few months through the elimination of bottled water purchases and the reduction of municipal utility bills.
And as you move through the final sections of the source material, there is a very deliberate sense of urgency. They are framing clean, unmonopolized water as a basic human right.
Yes, they do.
But the caveat is that in 2026, it is a right you have to actively engineer for yourself. The municipal grid cannot guarantee it, and the beverage corporations have a vested financial interest in selling it back to you at a premium.
Right, and to accelerate that transition, the author leverages some direct response incentives. They mentioned that the core Smart Water Box blueprint is currently bundled with supplementary guides designed to compound that self-sufficiency.
Right. The text highlights a greenhouse guide and an off-grid power hack guide. The logic is totally cohesive there. Once you secure an independent water supply, you can use it to secure an independent food supply and power the entire ecosystem off-grid.
Yeah, it's a closed-loop system.
Exactly. A closed-loop system of independence.
This raises a critical philosophical question, though, and it's one you, listening to this, should definitely consider.
What's that?
Well, the source boldly insists that your family's safety and hydration shouldn't have a price tag. Ideologically, that resonates, right?
Sure.
But practically, achieving the absolute independence they are pitching does require a price tag. It may not be a massive financial one, but it requires a significant investment of your time.
Right?
A willingness to learn basic mechanics, and the mental effort to break away from the undeniable convenience of the established grid.
That is the ultimate trade-off, isn't it? Convenience versus control. Point A, the grocery store shelf and the municipal tap is incredibly convenient, right up until the exact moment it fails. Turning a faucet requires zero effort, but it demands absolute trust in a decaying infrastructure. Assembling a smart water box requires an afternoon of focused work, sourcing parts, and, actually building a machine. But the yield is total control over your most vital resource.
It is the defining dilemma of modern infrastructure. Over the last century, we have outsourced our most basic survival needs. Water, food, power to massive, opaque, centralized systems. Reclaiming them requires deliberate action.
So let's recap the terrain we've covered today in this deep dive. We started by unpacking the illusion of the beverage aisle. The shocking reality that premium bottled water is often just municipal tap water laced with microplastics and marked up by 3,000%.
Right.
We looked at the structural reality of our failing 160-year-old municipal grid and how it forces households into a vulnerable state of dependency at point A.
And from there, we explored the thermodynamics of atmospheric water generation. We discussed how cooling ambient air below the dew point forces a vapor-to-liquid phase change.
Which is just so cool.
It really is. Tapping into the billions of tons of naturally distilled moisture suspended in the atmosphere, even in arid climates.
We then demystified the smart water box itself. It's a prime example of niche bending taking industrial refrigeration physics and translating them into a $50 Lego-style build that uses standard hardware parts to pull 40 gallons of water out of thin air on less power than a toaster.
Incredible.
And finally, we looked at the real-world validation from people like Mark and Sarah, who utilized this influencer science to permanently escape utility tenancy and create a financial escape hatch for their families.
I want to leave you with one final macro-level thought to ponder as we wrap up this deep dive.
Okay, let's hear it.
Throughout this discussion, we have focused on the micro-application. One household escaping a utility bill, one family securing clean drinking water in the desert. But zoom out and consider the systemic implications.
Oh, wow. Okay.
If millions of households suddenly adopted atmospheric generation and detached from the municipal grid, how would that reshape society?
That's a huge question.
Imagine the impact on urban planning if a city no longer needed to maintain millions of miles of subterranean cast iron pipes. Imagine the financial shockwave through multi-billion-dollar beverage monopolies when consumers realize they can harvest pure water from their own backyards for pennies.
They'd be terrified.
Oh, absolutely. And on a geopolitical level, imagine the easing of border conflicts and international tensions over river damming and aquifer rights. Could a decentralized $50 DIY box literally alter the balance of global power?
That is an absolutely staggering thought. To trace a line from a plastic bottle on a convenience store shelf all the way to shifting global geopolitics,
It's all connected.
it really exposes how fundamentally interconnected our infrastructure and our independence truly are. Well, thank you so much for joining us on this deep dive.
Yeah, thanks for listening.
The next time you find yourself staring at that wall of perfectly lit, incredibly expensive bottled water, just remember the phase change of condensation, the microplastics, and the reality that you might be paying rent to a landlord who isn't looking out for you. Keep questioning the systems you rely on, keep exploring your options for independence, and we will see you on the next deep dive.